So, hello students. So, this session is all about playing with numbers, and it is like related to your test of divisibility context. Okay, so you need to be you need to be good with tables to understand this. Yeah, with your tables. And what is it all about? I will know given a number whether it is divisible by 11, whether it is divisible by 9, and so on. So, coming back to the representation of numbers. Let's say, for example, 35. Okay, so I have the units place or the ones place and the tens place. How do I represent 35? 10 into 3, 30 plus 5 into or 1 into 5. 1 into 5, isn't it? That gives me 30 plus 5, which is 35. So in the decimal system, if I'm going to represent the number, this is how I would represent. This is the expanded form of the number, a generalized form. So if I'm given any number, let's say I don't know the digits, then I don't know something, and we know it, we take it as x and y as in algebra. So x and y. So x is in the tens place, y is in the ones place. So how do I represent the number? 10 into x plus 1 into y. 1 into y is y. Okay. So I'll just show you a few things here, because we are actually not going very deep into playing with numbers or test of divisibility right now here in this session. So what I do, I'll swap the positions of x and y. So this is the old number. The new number is where your x and y positions are swapped, as in y comes to the tens place, x comes to the ones place. This is the new number. See, I've marked it here. So what is the representation? Obviously, as you know, 10 into y plus 1 into x, or 10y plus x. Okay. So now, if you're going to add the numbers, okay, that is the old number plus the new number. Let's see what happens. Old number plus new number. 10x plus y. I'm adding that to 10y plus x. So what do I get? 10x, 1x, like terms you can add, isn't it? 11x. 1y and 10y is 11y. That will be 11 times x plus y. So what did I do? I took a number. I swapped the position of its digits, a 2-digit number here right now. Okay. So I took a 2-digit number. I swapped the position of its digits. I got a new number. I added the old number and the new number. You see, the old number and the new number, I've added them, and I got the number like this. I can take out 11 common, and x plus y is inside. So what does this mean? The sum of the old number and the new number is divisible by 11. It goes exactly by 11. It also goes exactly by x plus y. X plus y is sum of the numbers. So to make this point a little clear, I'll just go ahead with, let's say, I'll just take a simple number, 43. Okay. Ones place is 3 and tens place we have 4. This is the old number, right? I swap the digits. What do I get? I get 34, 3 and 4. Tens place and ones place. So we get tens place and ones place. So that is after swapping. Now I'll add the old and the new numbers. Old plus new. What do I get? 43 plus 34, which is 77. Okay. So that I can write as 11 into 4 plus 3, which means this 77 number is divisible by 11, isn't it? It is also divisible by the sum of the digits. Sum of the digits are 4 and 3. So 4 and 3, which is 7. So this is it. Just to give you another example, let me go with, let's say, 85. Okay, that is the old number. Old number is 85. Ones place, tens place. I swap the positions. I get 58. Okay, this is the new number. Now I add 85 and 58. So I get 143. Now 143, I can write 143 as 11 times 8 plus 5. That means 143 is divisible by 11. 11 13s are, isn't it? 143 is also divisible by 8 plus 5, which is 13. Sum of the digits, 8 and 5. Okay. So this is about the sum of the digits. So 143 will go by 11, because 11, if you do, we get 11 13s are 143. So it's pretty simple. So this trick will work very nice for 2-digit numbers. Now, this is just an observation that you have seen. What if I take the difference? The same thing. Let's say 85 and 58. Okay, there's ones place, there is tens place. This is the old number. There is ones place, tens place. After swapping the positions, you're getting the new number. This is the new number. So what do I get? We've already seen what happens when we add. When we add, we're going to get a new number, which is divisible by 11, which is also divisible by some of the digits. Now, what if I take the difference? Okay, bigger number is 85 minus 58. What will that be? 77. Sorry, 27. Okay, 27. So 27 is the new number that I obtained. Now, what is this 27? 27 is divisible by what? 9. Okay, 27 is divisible by 9, as you can see. And of course, see, what is divisible by 9 will also always be divisible by 3 as well. Okay, next is, okay, let me go back to what I took earlier, 43 and 34, no? I took 43, ones place, tens place, we can recall, then we swapped, we got 34, ones place, tens place. Now we are going to take the difference. 43 minus 34 is how much? 9. And of course, 9 is divisible by 9, isn't it? That is it. So when you have a number, a 2-digit number, you swap the digits and you get a new number. The sum of the old and the new number is divisible by 11. It is also divisible by sum of the numbers. And then in case of subtraction, that is when you swap the digits, you get a new number. So the old number minus the new number, or new number minus whichever is bigger. If the bigger one, you subtract the smaller one. That resultant, or that difference, I could say, is divisible by 9. You can try with some more examples. Let's take 87 and 78. Okay, if I add 87 and 78, what do I get? 165. So I can write 165 as 11 into, what is 8? Sum of the digits, isn't it? I can write it as 11 into 15, which means 165 is divisible by 11. 165 is also divisible by 15, which is the sum of the digits. Now, let me take the difference. 87 minus 78 will be 9 in this case, and 9 is anyway divisible by 9. So I hope this information was helpful.